Let us start with the first chapter, Basic Aerodynamics. Under this chapter, we will be studying about the introduction, continuity equation, types of flows, momentum equation, Euler's equation, Bernoulli's equation, energy equation, drag, and finally flow separation. Let's start off with the introduction. In our day-to-day life, we are busy in our whole day tight schedule, but sometimes we will look around to the sky, we see number of planes, aircraft, flying machines, helicopters, etc. At that time, we might be in confusion that how they work, what exactly is happening there. So this presentation is your answer. What is aerodynamics? It is the study of motion of air when affected by a solid object. In the image here, we can see a ball and a green line. Those are not lines but are smoke visualizations. When the ball is stationary, you can see that the smoke is stable. But when the ball starts to rotate, the flow is being disturbed and the smoke is fully disturbed. This is the study of aerodynamics. It concerns with the air and other gaseous fluids and forces acting on objects in motion through air. Anything that moves through air reacts to aerodynamics, like a rocket blasting off the launch pad, kite in the sky, or moving car as air moves around it. What is basic aerodynamics? It is the science of the action of air on an aircraft. The rule of aerodynamics explains how an aeroplane is able to fly. Basic aerodynamics deals with calculating the velocity and pressure, which in turn allows us to calculate the forces acting on the aircraft. Let us look at an example. Consider an aeroplane flying at an altitude of 3 kilometers at a velocity of 112 meters per second. At a given point on the wing, the pressure and the air velocity are specific values dictated by the laws of nature. One of the objectives of the science of aerodynamics is to use these laws and give us methods to calculate the flow properties. In turn, such information allows us to calculate practical quantities such as lift and drag on the airplane. Take another example where the flow through a rocket engine of a given size and shape. If this engine is sitting on the launch pad and given amount of fuel and oxidizers are ignited in the combustion chamber, the flow velocity and pressure at the nozzle exit are again specific values dictated by the laws of nature. The basic principle of aerodynamics allows us to calculate the exit flow velocity and pressure, which in turn allows us to calculate the thrust. This chapter will provide the basic laws and concepts of aerodynamics and show how they are applied to solving problems. Let us walk through the roadmap so that we can get a better idea of what this presentation on aerodynamics is all about. First, we can identify two basic types of aerodynamic flows. Flow with no friction, called inviscid flow, and flow with friction, called as viscous flow. This is an important distinction in aerodynamics. Any real-life aerodynamic flow has friction acting on fluid elements moving within the flow field. However, there are many practical aerodynamic problems in which the influence of this internal friction is very small and it can be neglected. Such flows can be assumed to be no friction, can be analyzed as inviscid flow. Flow with no friction, the inviscid flow, are then categorized into momentum equation, which says force is equals to mass into acceleration, which gives Euler's equation and Bernoulli's equation. Second, energy equation, which says energy is conserved. And third, which says continuity equation representing mass is conserved. We will further look at the application for each. Flow with friction, which is viscous flow, gives drag and flow separation. Let us move on with continuity equation in our next session. Thank you.